For section 1.7, we're looking at inequalities. And the first thing we need to do is discuss what interval notation is. Instead of writing it in what's called inequality notation, which is what you're used to, this would be inequality notation. Interval notation basically tells us what would be shaded on a number line. So for 1a, x is less than -3. This would mean everything left of -3. So it goes infinitely to the left. So the way we write that is we just write negative infinity. Then we always put a comma in our interval notation. And this is going to go to -3. Now the other thing with interval notation is it either will have parentheses or brackets. And you can have both in a problem. Brackets mean basically like the same thing as could be equal to. So if I have like a greater than or equal to, I would use brackets. Parentheses mean it can't be equal to. So if I had just a greater than sign, for example. So on the -3, I'm going to put a parenthesis on that because there's not saying it could be equal to -3. And then infinities always have a parenthesis. For letter B, x is greater than or equal to 5. So this is saying my smallest number is 5, and it goes infinitely to the right. So that would be positive infinity. Notice we always write these left to right, small to largest. So do not write infinity to 5. That doesn't make sense. Infinity is bigger than 5. Now on this one, since it says could be equal to 5, we're going to bracket 5. But infinity is not a number, so we can't say that it goes to infinity. That's just the concept of going forever, so that will have a parenthesis on it. That's a parenthesis. Oh, I made it look worse. There we go. For letter C, this is bound between two things. X is bigger than -2, but less than or equal to 1. Well, it can't equal -2, so I'll put a parenthesis on that. It can equal 1, so I'll put a bracket on that one. For letter D, this one, x is smaller than -7. So just looking at the smaller than -7 part, that would be from -infinity to -7. And I put a parenthesis on -7. Or mathematically is going to be the union symbol. It's a big U. X is greater than or equal to 5. So that means from 5 to positive infinity. Since it could be equal to, we put a bracket. Infinity always has a parenthesis on it. E, F, and G are even simpler because we're basically given the symbols we need. And this is just a different way of doing the open circle versus closed circle stuff. That doesn't look right. Try that again. You probably did open and closed circles. We're doing parentheses and brackets, but they mean the same thing. So on E, this would be in interval notation, bracket -2 to 6, parenthesis on 6. And again, this is just saying all the numbers between -2 and 6 include -2. For letter F, everything left of -3, so that would be going to -infinity. And then there's a gap, that's where we're going to do that in union with everything from 3 to infinity. And for the last one, it's just everything left of -6, so we're going to go to -infinity, -6, and we'll bracket that. Remember, the bracket means include that number. Parenthesis means don't. So now we're going to get into solving inequalities. But when we get done, we're going to write our answer in interval notation. Remember, solving an inequality is just like a normal equation, except if we multiply or divide by a negative we have to flip the inequality. That's the only thing that changes. Otherwise, it's solving like normal. So if I subtract 2, I'd have negative 8x greater than 56. But now I would have to divide by negative 8. So I'm dividing by negative, so that is going to flip my inequality. X is less than negative 7. But then in interval notation, this would be negative infinity, negative 7. That's how I want to write my answer. For letter B, I've got x's on both sides, so I need to group those together. So I'll subtract the x over here. I'll add 2 over to the other side. So now I've got negative 3x less than or equal to 3. Now I have to divide by a negative. So again, that's going to flip my inequality. I get that x is greater than or equal to negative 1. So that would be bracket negative 1 to infinity. For letter C, a little more complicated, but again, we solve it like it's an equation. So if I distribute, I group my x's together. So if I subtract over an x, that'll give me a 2x. I really have 16 over here if I added those together. So I'm going to subtract over 16 to the other side. That would give me negative 11. If I divide by 2, I did not multiply or divide by a negative. So the inequality does not switch on this one. I get negative 11 halves. X is greater than or equal to negative 11 halves. So in interval notation, that would be bracket negative 11 halves. Ooh, that looks terrible. Let's try that again. To infinity. Letters D and E are compound inequalities. Notice I have 2 inequalities in here. I basically solve these as 2 separate problems at the same time. So I'm going to solve this inequality, which would mean I'd first start off by subtracting the 4 over. But then separately, I'm going to solve, let me erase that one, this inequality, which I would subtract 4 over to the right. But I'm just going to do them both at the same time. So I'm going to subtract 4 off of both ends. So that'll give me negative 14 less than 2x less than 2. Divide by 2. So I'd have negative 7 less than x less than 1. And so in interval notation, this is everything between negative 7 and 1, parentheses because I'm not including those. Be careful, that looks an awful lot like the point negative 7, 1, like an xy. You just have to know within the context of the problem, we're talking about everything that's between the numbers negative 7 and 1, not the point negative 7, 1. For letter E, again, this is a compound. I'm solving this inequality and this inequality just at the same time. So my first step here would be to multiply by negative 5. I'm going to multiply by negative 5 everywhere. I'm multiplying by a negative, so I'm going to flip my inequalities around right now so I don't forget. So I'd have 15. I still have 3x minus 4 in the middle. And negative 20. If I add 4, and then divide by 3, I'd have 19/3 greater than or equal to x greater than negative 16/3. Now realize that this one is written backwards. Remember, interval notation is always from left to right, smallest to largest. So my smallest is negative 16/3. Then x goes to 19/3. And I bracket that because it can be that. For the next problem, we have a word problem here. We want to find the interval where the product will at least break even. So we have a cost function and a revenue function. Well, revenue is what you bring in, cost is obviously what you spend. Well, if we want to at least break even, we want our revenue to at least equal or be better than our cost. So I want 60x to be greater than or equal to 50x plus 5,000. Then I'll at least break even or make some profit. So I've got a fairly simple equation here, or inequality, excuse me. So if I subtract over 50x, I'll have 10x. Divide by 10. So x in this was the number of picture frames. So basically, if they sell 500 or more, they'll at least break even. 500 would break even, more would start to give them profit. This, by the way, is not a very good business model. It costs them $50 per frame to make. They're only selling them for $60 per frame. That's not a good margin, so a bad business. The last concept we're going to talk about with inequalities are nonlinear ones. These get a little funkier. These you may not have seen before. You've probably seen a lot of what we already did, maybe not interval notation, but these get a little funkier. So we're going to make one side 0 on these. We're going to make sure the other side is completely factored. It might already be, or we might have to. Then we're going to find all zeros. Zeros mean what makes each factor equal 0. Those are going to split up the number line, and then we're going to test numbers in each interval. So first step is rewrite so one side is 0. I've already got that on 4a. I'm going to factor. It's already factored. I've got x minus 3, x plus 5. There's nothing else I can do with those. So I'm basically down to step 3 already. The zeros are what make the factor 0, the zero factor property. So that would be 3, because 3 makes the numerator 0, and negative 5. That makes the denominator 0. Now, these become critical points. So we're actually going to draw a number line. Negative 5 and 3. I basically split the number line into 3 regions. Stuff smaller than negative 5, stuff between negative 5 and 3, stuff bigger than 3. I'm going to test a number in each one of those regions and see if it makes the inequality true or false. So I'll start with a number to the left of negative 5, like negative 6. You can pick any number you want, though. That's over there. Now, how am I going to test it? I'm going to test it in the inequality, but I'm not even going to be worried about the numbers. I just want to know if things are positive or negative. So here's what I mean. If I plug negative 6 into the numerator, I know the numerator is going to be a negative number. I don't even care what number it is. If I plug negative 6 into the denominator, that's also going to be a negative. Well, a negative divided by a negative is positive. And ask yourself, okay, well, are positive numbers less than or equal to 0? No. Positive numbers are bigger than 0. So the number I tested here did not make the inequality work. That means anything that's to the left of negative 5 doesn't work. I'm going to put a little sad face over there. Nothing over there works. All right, now I'll test a number in between. 0 would be an easy number to test. And again, I only really care about if stuff is positive or negative. So if I plug 0 into the numerator, that would be negative. If I plug 0 into the denominator, that would be positive. A negative divided by a positive is negative. And I ask myself, hey, are negatives less than or equal to 0? Yes, they are. So that means things in the middle worked. And finally, I'll test something to the right of 3, like maybe 4. That would make the numerator positive. That would make the denominator positive. A positive divided by a positive is positive, but I wanted stuff that makes less than or equal to 0. So stuff over there did not work. So what worked were things between -5 and 3. Okay, now I need to figure out what symbols I'm going to put on those numbers. This is where it gets a little trickier even. It does say for the original problem, less than or equal to. So I would think brackets, but I cannot put a bracket on -5. It has to be a parenthesis on -5. And the reason is -5 makes the denominator 0. Thou shalt not divide by 0. I can put a bracket on 3 because 3 makes the numerator 0. That's perfectly allowed. So my answer is everything between -5 and 3 include 3. So my interval answer, parentheses -5, 3, bracket. On letter B, okay, the first thing was rewrite, so one side is 0, done. Factor the other side. All right, this one's not factored, but it's a pretty fast factoring one. I would have x plus 7, x minus 5. Okay, step 3 is to find the zeros and use those to split up the number line. Well, my zeros would be -7 and 5. So I'm going to move my -7 over a little bit so I got a little more space. I'm going to test numbers in each region. And now I'm going to test them into my factored form, because if I do it in this form, all I'll really care about again are positives versus negatives. So if I test a number to the left of -7, like -8. -8, if I plug it into the first factor, that would be negative. If I plug it into the second factor, that would be negative. A negative times a negative is positive. I want stuff that is greater than or equal to 0 on this problem. Positives are, so this worked. Things over there worked. If I test a number in between, like 0, 0 would make the first factor positive. 0 would make the second factor negative. That would be a negative. That's not what I want. I want stuff bigger than or equal to 0, so that did not work. And if I test a number to the right of 5, like maybe 6, 6 would make the first factor positive. 6 would make the second factor positive. Again, I'm plugging these in for x. That would definitely be bigger than or equal to 0, so stuff over here worked. So this is the one where it's the stuff in the middle didn't happen, but the stuff on the ends did. Now, since this one does not have any division, the first problem, again, first problem had division, so I had to be worried about that. I don't have to worry about dividing by 0. The problem says could be equal to, so I can put brackets on them and not have to worry about dividing by 0. So I'm going to bracket -7 and shoot to the left. I'm going to bracket 5 and go to the right. And so my interval solution is going to be negative infinity to negative 7 bracket in union with 5 to infinity. For the last one, we've got more work to do because it's not set to 0 yet. So the first thing I'm going to have to do is I'm going to subtract over the 2. Now it's to 0. I now have to combine the left side into a single fraction. So I basically need to multiply the negative 2 times x plus 5. Get a common denominator. So I would have 10, careful, negative 2 times x, negative 2 times 5. So I would have 10 minus 2x minus 10 over the common denominator of x plus 5. So that would simplify into negative 2x over x plus 5 less than 0. Okay, so now it's ready to find the zeros. Be careful. The number that makes the numerator 0 is 0. It's saying negative 2 times something equals 0. Well, that's something would have to be the number 0. So 0 is a 0, and negative 5 is a 0. I'm going to do the testing now, and I'm testing in this part here. So if I plugged in something left of negative 5, like negative 6, that would make the numerator positive because I'm multiplying it by a negative. It'll make the denominator negative. I want stuff to be less than 0. Positive divided by a negative is negative. That is less than 0. That's what I wanted. If I test a number in between, like say, I don't know, negative 2. Make the top positive. It'll make the bottom positive. That's not what I want though, so that did not work. And I'll test a number to the right. Oops. To the right of 0, 1 would be easy enough. So that would make the top negative and the bottom positive. That is what I want. I want stuff to be smaller than 0, so that worked. And so it's stuff on the ends. This problem, I don't have to worry about the division by 0 because it did not say anything about being equal to, so we're okay there. So it's definitely going to be parentheses. So I'm going to have a parenthesis on negative 5, shooting to the left. A parenthesis on 0, shooting to the right. And so my interval notation answer would be negative infinity, negative 5, in union with 0 to infinity. That does it for 1-7.